66 million years ago, a rock the size of a city hit Earth. What followed was not just a disaster, it was a reset. Within hours, the sky was on fire. Shock waves rolled around the entire planet. Walls of water surged over coastlines. And then, something worse than all of it, the light went out. Dust and ash filled the atmosphere and blocked the sun for months, maybe years. Plants stopped growing. The animals that ate them began to starve. And then, the animals that ate those animals began to starve. The food chain didn't crack at the top, it collapsed at the bottom. Creatures that had ruled this planet for over 160 million years, animals so successful, so dominant, so deeply written into the fabric of life on Earth, were gone, not weakened, not reduced, gone. The skies emptied, the oceans lost their giants, the land fell quiet in a way it hadn't been since before complex life existed. But in the rivers, in the swamps, barely moving, barely breathing, waiting at the waterline the way they always had, something survived. An animal that had already lived through hundreds of millions of years of change. It didn't rise to replace the dinosaurs. It didn't expand to fill the silence. It just stayed, and that somehow was enough. But why? What specifically allowed this one lineage to hold on when so much else let go? Today, we answer that question and the conditions that made survival possible. Now, let's go back to the end of the world. Long before the silence that would follow, the planet moved with a steady, crowded rhythm, every surface occupied, every layer of air and water alive with motion. The land did not feel empty or wild in the way it might seem now. It felt complete, as if every space had already been claimed and understood by something that belonged there. Forests stretched in dense, humid expanses, their canopies thick with broad leaves that caught a sun warmer than today's. Ferns and flowering plants spread across the ground in tangled abundance, drinking in the light and feeding a vast web of life. Insects drifted through the heat in quiet clouds, and beneath them, herds of immense herbivores moved with slow certainty, their presence shaping the vegetation as much as the climate itself. Each step pressed into soft earth, each movement part of a balance that had settled over millions of years. Above them, the air was not empty. Wings carried shadows across the landscape, not of birds as they are now, but of larger forms, gliding and circling with effortless control. Along the edges of this living tapestry, predators watched and waited, their existence tied directly to the abundance below. Nothing lived in isolation. Every creature, from the smallest to the largest, was linked by invisible threads of energy, each dependent on the steady flow of life moving upward from the soil. The oceans mirrored this fullness. Warm waters spread far beyond modern coastlines, rising over low continents and creating shallow inland seas that shimmered under the same generous sun. Within them moved reptiles of great size and quiet power, bodies built for gliding through vast distances with minimal effort. Schools of fish shifted like living currents, and beneath them, deeper forms moved unseen, part of a system as intricate and interwoven as any forest. Between land and sea, wetlands stretched in wide, slow networks. Rivers branched and rejoined, feeding swamps where water and earth blended without clear boundary. Here, life adapted to both realms, existing in a space that changed with each season but never fully disappeared. The air carried the scent of decay and growth at once, a constant cycle unfolding just below the surface. Within these waterways, early crocodilians held their place with quiet consistency. Their bodies were already shaped for patience, their senses tuned to the subtle movements of water and the faintest disturbances along the banks. They did not dominate the land like the great herbivores, nor did they command the skies or the open ocean. Instead, they occupied the edges, the margins where different worlds met, drawing from both without fully belonging to either. This position offered a certain kind of stability. While other creatures relied on specific plants, precise temperatures, or particular prey, these semi aquatic hunters moved between options. Fish, small animals, and whatever drifted into reach became part of their diet. Their lives were not defined by a single path, but by a quiet flexibility, a way of existing that adapted to the shifting conditions of water and shore. All of it was held together by a climate that rarely faltered. Warmth spread evenly across the globe, reducing extremes and allowing ecosystems to expand into nearly every available space. Sea levels remained high, reshaping coastlines into broad, shallow habitats rich with life. Nothing seemed temporary. The patterns of growth, feeding, and movement repeated with a steadiness that gave the illusion of permanence. Yet this vast and thriving world was not built on independence. Its strength came from connection, and that connection also carried a hidden fragility. Energy flowed upward from plants to herbivores, from herbivores to predators, each step relying on the one before it. When the foundation remained strong, everything above it flourished. The balance held, quiet and complete, as if it had always been this way and always would be. At the edge of space, long before anything on the surface could sense it, a fragment of ancient rock traced a silent path toward Earth, carrying with it a force that had no equal in the planet's recent memory. It moved without sound, without resistance, crossing the final distance in moments that held no warning for the life below. It met the planet along a shallow tropical sea in the region now known as Chicxulub Crater. The water there was warm and relatively shallow, resting above layers of carbonate rock, rich in minerals that would soon be torn apart and lifted into the sky. In an instant, motion became release. The energy carried by that falling body converted into heat and pressure so intense that rock behaved like liquid, and air itself seemed to ignite. A flash spread outward faster than thought, a pulse of light brighter than the sun for those brief fractions of time. The surface below the impact did not simply break, it was driven downward and then rebounded, forming a vast crater while surrounding layers fractured in expanding rings. Shock waves surged through the crust, rippling across continents, setting off earthquakes that traveled through the planet with relentless force. Mountains shuddered, coastlines shifted, and the ground carried the memory of that impact far beyond its origin. From the point of collision, material rose into the sky in a towering column. Molten fragments, vaporized rock, and superheated gases surged upward and then outward, spreading across the upper atmosphere. As these fragments began their long descent back toward the surface, they re entered the air as countless points of heat, igniting vast regions below. Forests and plains, once sustained by steady growth, were overtaken by waves of fire that moved with a speed and scale beyond any natural burn. The air thickened with smoke and fine particles, each one part of a growing veil. Across distant oceans, the force of displacement sent water surging outward. Waves formed not from wind or tide, but from the sudden movement of the seafloor itself, rolling across basins and colliding with distant shores. Coastlines that had once shifted slowly over ages were struck in moments, reshaped by the energy carried from that single point of impact. Above it all, the atmosphere changed in a way that would linger far longer than the initial violence. The fine debris lifted high into the sky began to spread, carried by currents that encircled the globe. Tiny particles of dust, ash, and vaporized minerals formed a dense layer that dimmed the passage of sunlight. What had begun as a moment became a condition, one that altered the balance of heat and light reaching the surface. Temperatures shifted as the familiar cycle of day and warmth was interrupted. Without steady sunlight, the processes that sustained life at its foundation began to falter. The green surfaces that once captured energy slowed their quiet work, and the intricate web that depended on that flow began to strain. What remained in the wake of the impact was not a single event, but a chain of transformations, each linked to the one before it. The initial force had passed, yet its effects continued to unfold, carried through air, water, and living systems. The planet, once held in a stable rhythm, now moved under a different set of conditions, shaped by a moment that had touched every corner of its surface and every layer above and below. Light did not vanish all at once. It thinned, as if the day itself were being slowly erased, each hour dimmer than the last. What had once been a steady presence above the world became a distant, weakened glow, filtered through layers of fine particles suspended high in the atmosphere. The sky lost its clarity, turning from blue to a muted gray that settled over land and sea alike. These particles, lifted far beyond ordinary weather, formed a dense veil that encircled the planet. Carried by upper currents, they spread evenly, reducing the reach of sunlight across every region. Days continued to pass, but their brightness no longer carried the same energy. The warmth that once followed each sunrise began to fade, replaced by a quiet, persistent cooling. Temperatures dropped not in sudden extremes, but through a gradual withdrawal of heat. The surface of the Earth released energy into space without receiving enough in return. Nights grew longer in feeling, even when measured time remained unchanged. The difference between day and night blurred, both settling into a subdued, cooler state that reshaped the conditions for life. Within this dimmed world, the most fundamental process of the surface began to slow. Leaves that once captured sunlight with ease found less to gather. The intricate chemistry of photosynthesis, dependent on steady light, faltered under the reduced intensity. Energy that had flowed continuously from the sun into living systems became scarce, and with it, the quiet growth that sustained entire ecosystems. Plants did not disappear instantly. Many endured for a time, drawing on stored resources, continuing their cycles as long as they could. Yet without sufficient light, new growth weakened. Seeds failed to develop fully, and the spread of vegetation slowed to a near halt. Forests and fields that had once expanded now held still, their vitality gradually diminishing. As plant life weakened, the effect moved outward through the delicate connections that had once seemed so stable. Herbivores, dependent on a constant supply of vegetation, found less to sustain them. Their movements changed, ranging farther, searching through landscapes that no longer renewed themselves at the same pace. Each step carried them through a world that was subtly but steadily offering less. Predators, tied to those herbivores, felt the shift in turn. The balance that had once supported them became uncertain. Prey grew scarce, and the energy required to hunt began to outweigh the return. The intricate web of relationships, once supported by a reliable flow from sunlight to plant to animal, began to unravel from its base. In aquatic environments, the change followed a similar path. Phytoplankton near the surface, dependent on light penetrating the water, experienced the same reduction. Their numbers declined, and with them, the small organisms that fed upon them. This shift moved upward through marine systems, altering patterns that had long remained consistent. The cooling atmosphere reinforced these changes. As temperatures fell, metabolic processes slowed across many forms of life. Growth, reproduction, and movement all became more constrained. What had once been a world of continuous activity settled into a quieter, more limited rhythm. Time passed in this altered state, not marked by dramatic events, but by a steady persistence of diminished conditions. The absence of light, more than any immediate force, reshaped the planet's surface. It did not strike with impact or flame, but with duration, extending its influence across months and into years. In that extended dimness, the foundation of life, built upon the simple act of capturing sunlight, was no longer secure. The connections that had once held ecosystems together loosened, one by one, as the energy that sustained them became increasingly rare. Hunger arrived quietly, not as a sudden absence, but as a slow narrowing of what could be found. Across land and water, bodies that had once moved with steady purpose began to spend more time searching, covering greater distances for smaller returns. The balance between energy gained and energy spent shifted in subtle increments, each day drawing closer to a point where effort no longer met need. For the largest animals, this imbalance carried particular weight. Their size, once an advantage in stable conditions, required a constant intake of food to sustain muscle, movement, and internal heat. Growth had shaped them for abundance, not for scarcity. As available resources declined, these large forms faced a simple constraint. Their needs could not easily be reduced. Even brief periods without sufficient intake began to weaken them, and the margin for recovery grew thinner with each passing cycle. Smaller creatures experienced the same world under different limits. Their requirements were lower, their bodies able to function on reduced input for longer spans. Yet even for them, the pattern was changing. The sources they depended on became less predictable, appearing in shorter bursts and fading more quickly. Survival began to depend not only on strength or speed, but on how efficiently a body could endure uncertainty. Diet played a quiet but decisive role in this unfolding shift. Many species had evolved alongside particular plants or specific prey, their teeth, digestive systems, and behaviors finely tuned to those sources. In times of stability, this specialization offered precision and success. In a changing environment, it became a narrow path with little room to adjust. When familiar food sources declined or disappeared, these animals could not easily switch to alternatives. Their biology held them to patterns that no longer matched the world around them. Generalists, by contrast, carried a different kind of advantage. Their feeding habits were broader, less dependent on a single source, allowing them to take what was available rather than what was ideal. This flexibility did not guarantee abundance, but it extended the range of what could be used. In a landscape where options were shrinking, even a small expansion of possibility could make a difference. The pace of change itself shaped the outcome. Evolution, which had guided life through countless gradual transitions, moved across generations, adjusting traits over long spans of time. The conditions now unfolding shifted far more quickly. Temperature, light, and available resources altered within periods too short for many species to respond through adaptation alone. Bodies and behaviors that had once aligned with their environment found themselves mismatched, with no immediate path to correction. At the base of all these patterns lay the quiet collapse of the systems that sustained them. Energy had always entered the living world through simple processes, moving upward through layers of consumption and exchange. As those foundational processes weakened, every level above them felt the effect. Herbivores found less to consume, predators found fewer prey, and each connection strained under reduced flow. This unraveling did not proceed in a straight line. It moved through networks, touching one group, then another, spreading through relationships that had once seemed stable. The absence of one species altered the conditions for others, creating further shifts that echoed outward. What had been a tightly linked system began to loosen, its connections thinning until many could no longer hold. Within this changing world, survival was not determined by dominance or scale. It rested on the quiet details of physiology and behavior, on how a creature used energy, how broadly it could feed, and how long it could endure without certainty. As the environment continued to shift, these subtle differences shaped which lives could continue and which gradually faded from the pattern. Across continents that had long carried their weight, the great bodies began to thin from the world, not in a single instant, but in a sequence of quiet absences that spread from place to place. Paths once pressed deep into the ground went undisturbed. Feeding grounds that had shaped entire landscapes grew still. The presence that had defined the land for so long began to withdraw, leaving behind spaces that no longer held the same movement. For many of these animals, life had always been tied to the steady availability of plant matter. Their size, immense and deliberate, depended on constant intake. Long necks and broad jaws had evolved to gather vast amounts of vegetation, converting it into the energy required to sustain muscle, circulation, and heat. When that supply diminished, the effects reached them first. Each day without sufficient food reduced strength, and recovery required resources that were no longer present in the same measure. The connection between plant life and these herbivores had once been reliable, a continuous exchange that shaped both. As that connection weakened, the animals that depended on it found themselves moving through landscapes that no longer responded to their needs. Growth slowed, and with it, the renewal of feeding grounds. What had once supported herds across wide regions could no longer maintain them in the same numbers. Predatory dinosaurs, in turn, were bound to this system through the lives of those they hunted. Their existence depended on the presence of large herbivores, and as those populations declined, so did the opportunities for feeding. Hunting required energy, and with fewer successful pursuits, the balance shifted against them. Even the most efficient predators could not sustain themselves when the structure of the food web beneath them had begun to collapse. Reproduction added another layer to this gradual disappearance. Many dinosaurs relied on eggs, laid and left to develop in nests that depended on stable environmental conditions. These nests required warmth, protection, and time. In a world where temperatures were shifting and resources were uncertain, the process became more fragile. Eggs that might once have developed successfully faced conditions that slowed or halted their growth. Even when hatchlings emerged, they entered an environment already strained, with limited access to food and increasing competition for what remained. Generational recovery, which in stable times could restore populations, struggled to keep pace with the rate of decline. The time required for eggs to develop, for young to grow, and for adults to reproduce again did not align with the rapid changes unfolding across the planet. Each cycle brought fewer individuals forward, and the gap between loss and replacement widened. The disappearance did not follow a single path. It occurred across many regions, each shaped by local conditions, yet connected through the broader changes affecting the entire planet. Some areas may have held small groups for longer periods, brief pockets where survival extended beyond the general pattern. Yet these were exceptions within a larger trend, one that moved steadily toward absence. Over time, the land lost the forms that had once defined it. The great herbivores no longer moved through forests and plains, and the predators that followed them faded as well. The ecosystems that had supported them, already under strain, continued to shift without their presence. reorganizing around smaller and more adaptable forms of life. What remained was not a sudden emptiness, but a landscape in transition where the largest inhabitants had passed from the pattern. Their disappearance marked the end of a long chapter, one written over millions of years, now concluded through a series of changes that unfolded with quiet persistence rather than a single moment of finality. At the quiet edges of moving water, long before the great losses unfolded, a different lineage had already settled into its rhythm. It did not command the open plains or dominate the skies. Instead, it existed where boundaries softened, where land gave way to water, and the two blended into a shifting, living margin. Early crocodilians moved through these environments with a kind of restraint that contrasted with the larger bodies elsewhere. Their forms were low and elongated, limbs positioned to carry them across mud or into deeper channels with equal ease. Eyes and nostrils rested high on the head, allowing them to remain mostly submerged while still observing the world above. This simple arrangement shaped a way of life centered on stillness, patience, and sudden motion only when necessary. Rivers provided a constant thread through their existence. These flowing systems connected distant regions, carrying nutrients, sediments, and life between them. Along their banks, early crocodilians found both shelter and opportunity. They could remain hidden beneath the surface, conserving energy while waiting for movement at the edge of the water. When prey approached, the transition from stillness to action was brief and precise, guided by senses attuned to vibration and subtle shifts. Lakes and floodplains offered a different tempo. Here, water spread outward and slowed, forming broad, shallow areas that changed with seasonal patterns. During wetter periods, these spaces expanded, creating networks of channels and pools. As conditions shifted, they contracted, concentrating life into smaller regions. Crocodilians adapted to these changes without needing to leave entirely, adjusting their position within the same environment rather than abandoning it. Coastal regions extended this pattern further. Where rivers met the sea, brackish waters formed, blending fresh and salt into a gradient that supported a wide range of organisms. Some early crocodilians moved freely through these zones, tolerating variations in salinity that limited other species. This ability allowed them to follow food sources across different habitats, from inland waterways to the edges of the ocean. Diversity within this group was broader than what is seen today. Some species were relatively small, occupying narrow ecological roles within confined waterways. Others grew larger, capable of taking on more substantial prey or moving through more open environments. Variations in skull shape, tooth arrangement, and limb structure reflected different feeding strategies and movement patterns, each suited to a particular balance of land and water. This range of forms did not rely on rapid change, but on an underlying flexibility already present in their design. Their bodies supported both terrestrial and aquatic movement, not perfectly optimized for either, yet effective in both. On land, they could travel between bodies of water, seeking new areas when conditions shifted. In water, they found buoyancy and support, reducing the energy required to remain in place or to move quietly through their surroundings. Breathing patterns also reflected this dual existence. With lungs adapted for extended periods of submergence, they could remain below the surface while maintaining awareness of their environment. Their circulation allowed for efficient use of oxygen, supporting long intervals of stillness that matched their hunting style and reduced overall energy demands. All of these traits formed a way of life that did not depend on a single condition remaining constant. Water levels could rise or fall, prey could shift in type and availability, and temperatures could vary across regions. Early crocodilians did not need to follow one strict path through these changes. They occupied a space that allowed for adjustment, drawing from both land and water without being confined to either. In a world where many forms of life were closely tied to specific resources or conditions, this quiet flexibility stood apart. It did not draw attention, nor did it require dominance. It simply persisted along the margins, shaped by an environment that was always in motion and prepared, in ways not yet tested, for changes that would reach far beyond those shifting edges. There is a place where the surface never fully settles into one state, where ground softens into water, and water returns to ground with each quiet shift. In that boundary, life follows a different rhythm, one shaped not by permanence, but by constant adjustment. Early crocodilians lived within this changing edge, their existence defined by movement between two worlds rather than commitment to one. Their bodies carried this duality in every detail. Limbs allowed them to lift and move across land when needed, yet their weight found relief in water, where buoyancy reduced the effort required to remain still. Tails, strong and laterally compressed, guided them through currents with minimal disturbance. Even their skin, thick and patterned, offered protection in both environments, resisting abrasion from earth and the subtle pressures of water alike. In water, temperature shifted more slowly than in open air. Heat absorbed during the day lingered beneath the surface, while cooler conditions above did not penetrate as quickly. This created a kind of refuge, a space where extremes were softened. When the surrounding environment grew too warm or too cold, these animals could adjust their position simply by entering or leaving the water, allowing their bodies to remain within a narrower range of conditions. This ability to move between mediums also shaped how they responded to sudden changes. When disturbances spread across the landscape, whether from shifting climate or localized disruption, retreat did not require distance. A few measured steps could carry them from exposed ground into the concealment of a river or pool. There, beneath the surface, movement slowed, and the immediate pressures of the environment became less direct. Food sources followed similar patterns of variety. Along the water's edge, small animals gathered to drink, insects hovered, and fish moved just below the surface. By occupying this transitional zone, early crocodilians gained access to both terrestrial and aquatic prey. They were not limited to a single type of food or a single method of obtaining it. Stillness allowed them to wait, conserving energy until an opportunity presented itself, whether it came from above the water or within it. Their senses were tuned to this environment of overlap. Vibrations carried through water provided information about movement beyond sight. Subtle changes in pressure signaled the approach of potential prey. On land, vision and scent extended their awareness, guiding them toward areas where activity was more likely. This combination of sensory inputs created a continuous understanding of their surroundings, regardless of which medium they occupied at a given moment. Periods of inactivity were not a sign of weakness, but a central part of their strategy. By reducing movement, they conserved energy and remained less visible within their environment. Time passed without urgency, measured not by constant action, but by readiness. When conditions shifted, whether through temperature, water level, or the presence of prey, they adjusted without needing to abandon their position entirely. This way of life did not depend on stability in the broader sense. It depended on local balance, on the ability to respond to immediate conditions without requiring large-scale change. Water and land each offered advantages, and by existing between them, early crocodilians could draw from both while remaining insulated from the extremes of either. As the wider world began to experience increasing strain, this quiet flexibility became more than a way of living. It became a form of resilience, embedded not in strength or speed, but in the simple ability to shift position, to wait, and to endure within a space that was always in motion. Beneath the surface of still water, motion is reduced to the smallest necessary movements, a gentle adjustment of position, a slow turn guided by muscle that expends little effort. Within that stillness, a different kind of pace governs the body, one that does not demand constant input, one that stretches time between moments of need. Crocodilians carry an internal rhythm shaped by low metabolic demand. Their bodies do not require continuous feeding to maintain function. Instead, energy is used carefully, distributed in a way that favors endurance over intensity. Muscles are engaged only when required, and much of their time is spent in states of minimal activity, conserving what has already been gained. This efficiency begins at the level of temperature regulation. As ectothermic animals, their internal heat is influenced by their surroundings rather than generated at a high constant rate. This reduces the need for continuous energy intake, allowing them to function without the constant drive to feed that defines many warm-blooded animals. When conditions are favorable, they can become more active, but when resources decline, their bodies naturally shift toward conservation. Digestion follows a similar pattern of efficiency. When food is available, it is processed slowly and thoroughly. Powerful digestive systems extract as much energy as possible from each meal, breaking down material that would be difficult for many other animals to utilize. Once that energy is stored, it can support the body for extended periods, reducing the frequency of feeding required for survival. This capacity allows crocodilians to endure long intervals without food. Weeks can pass, even months, during which they remain alive and functional, drawing on reserves accumulated earlier. Activity during these periods is limited, not through weakness, but through a deliberate reduction in energy use. Movement becomes measured, and time is spent in positions that require little exertion, often within water where buoyancy further decreases physical demand. Circulatory and respiratory adaptations support this slow pace. Their hearts and blood flow systems allow for adjustments in oxygen distribution, matching supply with reduced demand. During periods of inactivity, breathing can slow and oxygen use becomes more efficient. This integration of systems creates a body capable of sustaining itself under conditions that would challenge species with higher metabolic needs. In an environment where food becomes scarce, this difference carries significant consequences. Animals that require frequent intake face immediate pressure when resources decline. Their bodies, accustomed to regular feeding, begin to weaken quickly without it. Crocodilians, by contrast, are not tied to such immediate cycles. Their survival is not dependent on daily success, but on their ability to extend the value of each successful feeding event over long spans of time. This does not eliminate the need for food, but it changes the scale at which that need operates. Rather than a constant requirement, it becomes periodic, allowing these animals to wait for suitable opportunities rather than expending energy searching continuously. Patience, in this context, is not only a behavioral trait, but a physiological one, embedded in the way their bodies manage resources. As conditions fluctuate and availability becomes uncertain, this slow metabolism provides a form of stability. It aligns with environments where abundance cannot be relied upon, where survival depends on enduring gaps between moments of opportunity. In such settings, efficiency outweighs speed, and the ability to persist with minimal input becomes a defining advantage, shaping a way of life that can continue even when the surrounding world offers less. Along the shifting margins where water meets ground, meals do not arrive on a fixed schedule, nor do they take a single form. Movement at the surface, a drifting body carried by current, a small creature pausing at the edge, each becomes part of a landscape of possibility rather than certainty. In such places, survival favors those that do not wait for one specific offering, but remain open to whatever appears within reach. Crocodilians develop this openness as a quiet habit rather than a dramatic strategy. Their feeding behavior is not built around pursuit alone, but around presence. By remaining still for long stretches, they allow the environment to bring opportunities toward them. When something enters that narrow range, the response is brief and efficient, using stored energy rather than continuous effort. This approach reduces the cost of feeding, making each successful capture more valuable. What they consume reflects this flexibility. Fish moving beneath the surface provide one source, their motion detected through subtle changes in water. Small animals approaching the edge offer another, drawn by the need to drink or cross between habitats. Even the remains of other creatures, carried by currents or left behind after other events, become usable. Carrion, often overlooked by more selective feeders, can sustain these animals when fresh prey is scarce. Their digestive systems are capable of breaking down a wide range of material, extracting energy from sources that vary greatly in form and condition. This breadth of diet removes dependence on any single chain of events. If one type of prey declines, others may still be present. The connection between predator and environment becomes less rigid, allowing adjustment without the need for rapid change in anatomy or behavior. In a world where conditions are shifting, this absence of strict preference becomes a quiet strength. Timing also plays a role in how this feeding pattern unfolds. Rather than seeking constant intake, crocodilians rely on intermittent success. A single substantial meal can support them for extended periods, reducing the pressure to find food every day. This allows them to wait through intervals when little is available, conserving energy until conditions improve or an opportunity arises. The rhythm of feeding becomes uneven, shaped by availability rather than routine. Their position between water and land expands the range of what can be encountered. Aquatic prey moves through currents and channels, while terrestrial animals interact with the edges for their own needs. By occupying this transitional space, crocodilians gain access to both, increasing the likelihood that something will pass within reach over time. They do not need to travel far to change their options. The environment itself brings variation to them. This adaptability extends to different stages of life as well. Younger individuals often consume smaller prey, insects, or small fish, adjusting their diet as they grow. Larger individuals can take on more substantial animals or rely on remains that provide greater energy. Throughout these changes, the underlying pattern remains the same, a willingness to use what is available rather than seek what is ideal. As ecosystems become less predictable, this opportunistic approach reduces vulnerability. When familiar sources decline or disappear, there is no single loss that determines survival. Instead, each new condition is met with the same quiet readiness, a capacity to accept whatever form of nourishment appears. In this way, feeding becomes less about preference and more about persistence, a steady interaction with an environment that no longer offers consistency, yet still provides enough for those able to use it. Time in certain bodies can be stretched without breaking. It does not rush forward or demand constant motion, but settles into longer intervals, where change is measured in quiet adjustments rather than continuous activity. Within this slower passage, some animals found a way to endure, not by resisting the conditions around them, but by easing into them, reducing their presence until the demands of survival became smaller. Crocodilians carry this capacity as part of their natural rhythm. When the environment offers less, their bodies respond not with urgency, but with restraint. Activity decreases, movement becomes minimal, and long periods pass in near stillness. This is not a collapse of function, but a deliberate shift toward conservation, where every process is adjusted to use less energy. Their muscles remain capable, yet they are not engaged unless necessary. A crocodile may rest for extended stretches, partially submerged or settled along the edge, its body supported by water or ground in a way that reduces strain. Even posture reflects this efficiency, limbs tucked, weight distributed, minimizing the effort required to remain in place. From the outside, this stillness can appear absolute, yet internally, essential processes continue at a reduced pace. Breathing slows in parallel with this reduction. The intervals between breaths lengthen, and oxygen is used more carefully. Circulation adjusts to match this slower demand, delivering what is needed without excess. The coordination between these systems allows the animal to remain alive and aware while expending far less than it would during active periods. This low energy state extends beyond moments of rest and becomes a sustained condition when resources are limited. Days blend into longer spans where little changes in outward behavior. The need to search for food diminishes, replaced by a reliance on stored energy and the expectation that opportunities will return in time. Rather than moving constantly in search of uncertain gains, crocodilians allow time itself to become part of their strategy. Stillness also reduces exposure. Movement can draw attention, both from potential prey and from other animals competing for the same limited resources. By remaining quiet and unobtrusive, they lower the chance of unnecessary encounters. Their presence becomes part of the background, integrated into the environment rather than standing apart from it. This approach contrasts with species that rely on continuous activity to survive. For those animals, the need to move, to hunt, or to forage does not pause easily, even when conditions worsen. Energy expenditure remains high, and the absence of food quickly becomes critical. Crocodilians, by comparison, shift into a mode where waiting is not a delay, but a functional state, one that aligns with the reduced availability of resources. Over extended periods of hardship, this capacity to wait becomes increasingly important. It allows survival through stretches where immediate opportunities are rare or absent. The body, already adapted to function on minimal input, continues to operate without reaching the limits that would cause failure in more demanding systems. As the environment continues to fluctuate, this low energy existence provides a form of continuity. It does not solve the absence of resources, but it reduces the impact of that absence, extending the time an individual can persist. In this quiet endurance, survival is shaped not by action, but by the ability to remain, to hold position within a changing world until conditions shift once more. Not all parts of the world changed at the same pace. While the open land above faced shifting conditions that moved quickly across vast distances, water held its own tempo, absorbing and releasing change more gradually. Beneath the surface of rivers and lakes, the surrounding environment was filtered through layers that softened what arrived from above, creating a different experience of the same moment. Water carries heat differently than air, storing it and distributing it over time. When temperatures began to fall, this stored warmth did not disappear immediately. It lingered, maintaining conditions that were less severe than those found on exposed ground. In deeper channels and sheltered basins, this effect was even more pronounced, forming pockets where change unfolded more slowly. For animals within these spaces, the difference was not absolute safety, but a gentler transition. Light, reduced in the atmosphere, also entered the water in diminished form, yet it did not vanish entirely at once. In shallow areas, enough energy continued to reach the surface layers to support limited activity. Small organisms persisted, sustaining a reduced but functioning system. These aquatic food webs were simpler and more fragile than before, yet they endured longer than many terrestrial systems that depended more directly on constant sunlight. Rivers continued to move, carrying nutrients from one place to another. Even as conditions shifted, this movement helped maintain pockets of life along their course. Organic material, both living and decaying, flowed through these channels, providing intermittent sources of energy. Lakes, more contained, relied on what remained within them, but their stability allowed for a slower decline rather than an immediate collapse. For crocodilians, these environments offered a form of protection shaped not by isolation, but by buffering. The water itself acted as a barrier against rapid fluctuations. When the air above carried ash, heat, or cold, the surface absorbed and moderated these effects before they reached deeper levels. By remaining submerged or partially hidden within these systems, crocodilians experienced a reduced intensity of the surrounding changes. Fires that spread across land found their limits at the edges of water. The boundary between flame and river created a natural interruption where advancing fronts could not continue in the same way. Along these margins, animals within the water were shielded from direct exposure. Smoke and particulate matter still moved across the surface, yet the immediate danger of burning passed above rather than through these aquatic spaces. Atmospheric disturbances, carried by wind and suspended particles, altered conditions everywhere, but their direct impact was lessened beneath the surface. Water filtered what entered, dispersing it and reducing concentration. This did not remove the effects entirely, but it changed their intensity, allowing life within these systems to continue under less extreme pressure. The structure of aquatic environments also provided physical refuge. Depth offered concealment, while submerged vegetation and irregular terrain created spaces where animals could remain undisturbed. These features allowed crocodilians to maintain their low energy states with minimal interruption, further reducing their exposure to changing conditions. Within this moderated world, survival did not depend on resisting every external force. Instead, it relied on occupying a space where those forces were softened, where time moved differently, and where the decline of surrounding systems was less immediate. Rivers and lakes became more than habitats. They became buffers, extending the period during which life could persist. As the broader environment continued to shift, these aquatic refuges held fragments of the earlier balance, not unchanged, but less disrupted. Within them, certain forms of life found the conditions needed to endure, carried forward by the quiet stability that water could still provide. Along quiet banks where soil holds its shape, small openings appear that seem at first like irregularities in the ground. They lead inward, not far, but far enough to separate what happens outside from what remains within. In these enclosed spaces, the surface world becomes distant, its fluctuations softened by layers of earth that absorb and delay change. Some crocodilians used such spaces as part of their routine long before conditions grew unstable. With slow, deliberate effort, they shaped shallow tunnels or widened natural hollows, pressing into damp soil where the ground was firm enough to hold but soft enough to yield. These dens were not elaborate structures, yet they served a clear purpose, offering a place where the body could rest in relative protection. Within a burrow, temperature follows a different pattern than at the surface. Heat from the day does not reach as deeply, and cold from the night is reduced before it settles inside. The surrounding earth acts as a buffer, moderating extremes and creating a more consistent environment. For an animal whose physiology responds directly to external conditions, this stability reduces the need for constant adjustment. Moisture also lingers in these spaces, held within the soil and the air enclosed by it. This helps prevent excessive drying, maintaining conditions that support basic physiological balance. The body, already adapted for conserving energy, benefits from this steady environment, allowing processes to continue without added strain from fluctuating heat or exposure. During periods when the surface becomes unsettled, these shelters take on additional significance. Material carried through the air, whether fine particles or larger debris, remains largely outside. The entrance may admit a small amount, but the interior remains comparatively undisturbed. By withdrawing into these spaces, crocodilians reduce their contact with whatever moves across the landscape above. The depth of a burrow does not need to be great to provide this effect. Even a short passage into the ground creates a separation between the animal and the immediate conditions outside. Sound becomes muted, light fades, and movement slows. This environment encourages stillness, aligning with the broader pattern of reduced activity already present in their behavior. Such shelters also offer a form of concealment. While the wider environment shifts and other animals move in search of resources, a crocodilian within a burrow remains largely hidden. This reduces the likelihood of encounters that might require energy to resolve, whether through conflict or escape. In times when energy must be conserved, avoiding unnecessary interaction becomes as important as finding food. The use of these spaces is not constant, nor does it replace the broader connection to water and open ground. Instead, it adds another layer to a flexible way of living. A crocodilian may move between water, bank, and burrow as conditions change, selecting the environment that best matches its immediate needs. This ability to choose among different forms of shelter increases the range of situations it can endure. Over time, these microenvironments, small and often unnoticed, contribute to survival in subtle ways. They do not prevent change in the larger world, but they reduce its direct impact on those within. By offering stability, protection, and a place for continued stillness, burrows become part of a quiet network of strategies that support endurance through prolonged difficulty. In the presence of widespread disruption, these modest shelters provide a kind of continuity. Within them, the pace of change slows, and the essential processes of life continue with less interference, sustained by the simple protection of Earth, shaped just enough to hold against the shifting world outside. In water where clarity fades and movement slows, the air itself becomes less available, dissolved in smaller amounts and unevenly distributed through the layers below the surface. Many forms of life depend on a steady exchange of oxygen, drawing it in at a constant rate, their survival tied to how much can be taken in and how quickly it can be used. In these diminished conditions, that exchange becomes more difficult, and for some, it cannot be sustained for long. Crocodilians approach this limitation with a different balance. Their bodies are not built for continuous high intake, but for measured use. When oxygen is scarce, They do not attempt to maintain the same level of activity. Instead, their systems adjust, reducing demand to match what is available. This shift allows them to remain functional, even when the surrounding environment offers less than what many other animals require. Their lungs are structured to support this efficiency. When they surface to breathe, air is drawn deeply and distributed in a way that maximizes exchange. Oxygen binds within the blood and is carried through a circulatory system capable of directing it where it is most needed. At the same time, their physiology allows for adjustments that slow the rate at which oxygen is consumed, extending the usefulness of each breath. Between breaths, time can lengthen significantly. A crocodilian resting beneath the surface may remain submerged for extended periods, its body operating at a reduced pace. The heart rate slows, circulation becomes more selective, and non essential processes are minimized. This controlled reduction lowers the overall demand for oxygen, allowing the animal to persist without frequent access to fresh air. In waters where oxygen levels decline due to changes in temperature, organic decay, or limited circulation, this capacity becomes particularly valuable. Many aquatic organisms rely on extracting oxygen directly from the water through gills, and when levels drop, their ability to function is quickly compromised. Crocodilians, by relying on lungs and periodic access to the surface, are less directly affected by these fluctuations within the water itself. Even so, they are not entirely independent of their surroundings. Poor water quality can still influence their behavior and distribution, yet their tolerance allows them to remain in environments that would challenge more sensitive species. They can occupy areas where oxygen levels vary, adjusting their activity and breathing patterns in response, rather than being forced to leave immediately. This flexibility extends to conditions where the water carries suspended material, reducing clarity and altering the balance of dissolved gases. In such environments, the ability to slow breathing and reduce oxygen demand provides a margin of endurance. Rather than requiring constant movement or relocation, crocodilians can remain within familiar territory, conserving energy while conditions fluctuate. Their blood chemistry also supports this endurance. The way oxygen is bound and released allows for efficient use even at lower concentrations. Combined with the ability to tolerate brief periods of reduced oxygen availability, this creates a system that can bridge gaps between breaths or between access to more favorable conditions. As environments become degraded, whether through natural processes or broader changes, this set of traits forms a quiet advantage. Survival does not depend on maintaining ideal conditions, but on the ability to continue functioning when those conditions decline. By aligning their physiology with reduced demand and efficient use, crocodilians can persist in waters where oxygen is limited, extending their presence into spaces where others cannot remain for long. In quiet stretches of shoreline, where the ground holds moisture and warmth, small disturbances appear in the soil, subtle mounds shaped by careful movement rather than force. Within these layers of earth, life begins in a form that does not move or feed, yet carries the full potential of the animal it will become. For crocodilians, reproduction unfolds in this hidden space, where the surface world is held at a distance. Eggs are placed beneath soil or within dense vegetation, their position chosen with attention to temperature and protection. The covering of Earth forms a natural barrier, reducing exposure to the direct conditions above. Heat is absorbed and released slowly through the surrounding material, creating a more stable environment for development. Even as external temperatures fluctuate, the interior of the nest changes at a gentler pace. This buffering effect extends to other elements of the environment. Fine particles moving through the air settle on the surface, yet only a small portion reaches the eggs below. The layers of soil and plant matter filter what passes through, limiting the direct impact on the developing embryos. Within this enclosed space, the immediate disturbances of the outside world are softened, allowing development to continue with fewer interruptions. Moisture within the nest also plays a role in sustaining these early stages of life. The surrounding earth retains water, maintaining conditions that prevent excessive drying. This balance supports the processes unfolding within each egg, where growth depends on a consistent internal environment. Too much variation can halt development, but the nesting strategy helps maintain the necessary stability. Unlike many animals that require direct care throughout early development, crocodilian embryos progress within these protective structures without continuous external input. The energy required for growth is contained within the egg itself, reducing dependence on immediate environmental resources. This independence allows development to continue even when surrounding conditions are less favorable. Reproduction, in this way, is not halted entirely by instability. While many nests may fail under harsh conditions, some remain intact, shielded enough to carry embryos through to completion. The placement of nests in suitable locations increases the likelihood that at least a portion will succeed. Variation in nesting sites spreads risk, ensuring that not all offspring are exposed to the same level of disturbance. When development reaches its final stages, hatchlings emerge into a world already changed. Their first movements are small and tentative, guided by instinct rather than experience. They are not yet suited for independence in the same way as adults, yet their early needs are modest. Small prey and sheltered environments can support them as they begin to grow. Survival at this stage remains uncertain, influenced by conditions that continue to shift. Many hatchlings do not persist, yet some find the necessary balance of shelter and food. Their small size reduces their immediate requirements, allowing them to exist within environments that cannot sustain larger animals. This continuation of reproduction, even at reduced levels, maintains a thread of continuity through changing conditions. Each successful nest contributes to the persistence of the lineage, carrying it forward through periods that challenge survival at every stage of life. Within these buried chambers, shielded by soil and shaped by careful placement, the beginnings of life endure. They do not require stability across the entire landscape, only within the narrow space that surrounds them, where development can proceed quietly until the moment arrives for emergence into whatever world remains above. Not every body carried the same weight through those changing conditions. Some forms were vast, shaped by abundance, while others remained closer to the ground, their scale requiring less from the world around them. Among crocodilians, many of the individuals that persisted belonged to this smaller range, their size aligning more closely with what the altered environment could still provide. A reduced body mass changes the relationship between an animal and its resources. Less energy is required to maintain basic functions, and the amount of food needed to sustain life decreases accordingly. In a landscape where availability has narrowed, this difference becomes significant. A smaller crocodilian does not need to secure large quantities of prey to continue functioning. Even modest intake, spaced over time, can be sufficient. This lower demand also affects how often feeding must occur. With efficient metabolism already extending the value of each meal, a smaller body stretches that advantage further. The intervals between feeding can lengthen without placing the animal under immediate strain. This reduces the urgency to search constantly, allowing more time to be spent in stillness, where energy use remains minimal. Movement, too, becomes less costly. A smaller frame requires less force to shift from one place to another, whether entering water, crossing short distances on land, or adjusting position within a confined space. These movements, though infrequent, are part of daily survival, and the reduced effort required for each contributes to overall conservation of energy. Within limited environments, size influences how many individuals can be supported at once. A given area can sustain a greater number of smaller animals than larger ones, as the total demand placed on available resources is distributed more evenly. This allows populations to persist in places where larger species would exceed the carrying capacity of the environment. Even when resources are scarce, the balance between supply and demand can remain within a range that supports continued survival. Younger crocodilians, which are naturally smaller, benefit from this balance during early stages of life. Their needs are modest, and the types of prey they consume are often more abundant or less affected by broader changes. As they grow, those that reach larger sizes do so gradually, with each stage supported by the conditions that remain available. This progression aligns growth with opportunity rather than requiring immediate access to large resources. The distribution of sizes within a population also creates a form of internal stability. Not all individuals compete for the same resources at the same time. Smaller animals focus on different prey than larger ones, reducing direct competition and allowing multiple size classes to coexist within the same area. This layered use of resources helps maintain population structure, even as overall availability declines. In contrast, very large animals face a narrower margin for survival. Their needs are greater, and the resources required to meet those needs are more limited. When supply decreases, the gap between requirement and availability widens quickly, leaving little room for adjustment. Smaller crocodilians, by requiring less, remain within that margin for longer periods. As conditions continue to shift, this alignment between body size and resource availability becomes a quiet advantage. It does not depend on rapid change or new adaptations, but on an existing balance that matches the altered environment. Within that balance, smaller bodies persist, sustained by what remains, carrying forward through a world that can no longer support the scale that once dominated it. The weight that once moved across open ground began to fade, not in a single moment, but through a gradual thinning of presence that altered the balance of life in quiet, far-reaching ways. Where large predators had once shaped the movement of other animals, their absence changed the patterns that followed, leaving behind a landscape that no longer carried the same pressure from above. These predators had occupied the highest levels of the terrestrial food web, their survival tied to the abundance of large herbivores and the stability of the systems beneath them. As those foundations weakened, the predators were among the first to feel the full effect. Their size required consistent success in hunting, and as prey became less available, each failure carried greater consequence. Over time, their numbers declined, and in many regions, they disappeared entirely. With their loss, a significant force within the ecosystem was removed. Predators do more than consume prey. They influence behavior, distribution, and the structure of entire communities. Their presence creates boundaries, guiding where other animals move and how they use the environment. Without them, those boundaries began to loosen, and the patterns that had been shaped by their influence shifted in response. For crocodilians, this change unfolded along the margins they already occupied. They had not competed directly with large terrestrial predators for the same roles, yet they existed within a broader system where those predators affected the availability and movement of potential prey. As the pressure from above diminished, the dynamics at the water's edge became less constrained. Fewer large predators meant fewer threats to crocodilians themselves. While adults were well protected by their size and armor, younger individuals were more vulnerable. The absence of dominant land predators reduced the number of encounters that could result in injury or loss, allowing more individuals to survive through early stages of life. This subtle shift increased the likelihood that juveniles could grow and contribute to the population. At the same time, the reduction in predation pressure altered how other animals approached water sources. With fewer threats present on land, some species may have moved more freely, changing the patterns of interaction at the edges of rivers and lakes. These shifts created new opportunities for crocodilians, not through direct competition, but through changes in the availability and behavior of potential prey. The absence of large predators also reduced competition for certain resources. While crocodilians did not rely on the same prey as many terrestrial hunters, there were overlaps in the broader network of life. With fewer predators drawing from this network, the remaining resources were distributed among fewer consumers. This eased the overall pressure on the system, allowing those that remained to persist with less competition. Stability began to emerge in small, localized ways. Without the constant influence of dominant predators, the environment at the water's edge settled into patterns that could be maintained with the reduced availability of resources. Crocodilian populations, already adapted to low-energy living, found themselves within conditions that supported gradual recovery rather than continued decline. This did not restore the world to its previous state, nor did it remove all challenges. The broader environment continued to shift, and many forms of life remained absent. Yet within this altered system, the removal of large predators created a space where certain species could endure with fewer pressures acting against them. In that quieter landscape, along the boundaries of water and land, crocodilians persisted, not by filling the roles that had been left behind, but by continuing within their own. The absence of those above them in the food web did not elevate them into dominance, but it did reduce the obstacles to survival, allowing their steady, patient way of life to continue within a world that had grown less crowded at its highest levels. Recovery did not arrive as a sudden turning point, but as a gradual return of quiet processes that had once been constant. Over long spans of time, the surface began to show small signs of renewal, not in broad sweeps, but in scattered patches where conditions allowed life to take hold again. These early changes were subtle, easily overlooked within the larger stillness that remained. Plant life led this slow rebuilding. In places where light and temperature reached a workable balance, simple forms began to spread. Growth was limited at first, constrained by the same conditions that had reduced it before, yet each new patch contributed to a larger pattern. Leaves emerged, small and sparse, capturing what energy was available and converting it into the beginnings of a renewed system. Over time, these patches expanded, connecting with one another and gradually restoring a base upon which other life could depend. This return did not follow a single path. Different regions recovered at different rates, shaped by local conditions and the lingering effects of earlier disruption. Some areas remained sparse for extended periods, while others supported more continuous growth. The landscape became a mosaic of stages, each representing a different point along the path of recovery. As plant life increased, it began to support small herbivores. These animals required less energy than larger forms and could survive on the limited vegetation that was available. Their presence marked a shift, indicating that the flow of energy from plants to animals had begun to reestablish itself. Populations grew slowly, each generation building upon the last, contributing to the gradual expansion of life across the surface. Predators followed in time, drawn by the increasing presence of prey. These early predators were often smaller and more adaptable than those that had come before, capable of adjusting to the variable conditions that still persisted. Their interactions with herbivores helped shape the developing ecosystems, reintroducing patterns of movement and behavior that had been absent during the period of decline. Within aquatic environments, similar processes unfolded. As conditions stabilized, microorganisms and small aquatic plants began to repopulate surface waters. This supported the return of small animals, which in turn provided resources for larger forms. Rivers and lakes, which had retained some continuity, became centers from which life could expand outward, linking recovering regions through the movement of water and organisms. Crocodilians remained present throughout this extended rebuilding. Their persistence allowed them to occupy roles within these emerging systems without needing to undergo significant change. As prey became more available, their feeding opportunities increased, supporting gradual growth in their populations. Yet their way of life remained consistent, aligned with the same patterns of low energy use and opportunistic feeding that had carried them through the earlier period. The passage of time, measured in millions of years, allowed these processes to continue without interruption. Each small increase in plant life supported more herbivores, which in turn supported more predators. The connections between these levels strengthened, forming networks that became more stable as they expanded. Complexity returned not through rapid transformation, but through accumulation, each step building upon the last. This long recovery did not recreate the world exactly as it had been. The composition of species changed, and new forms emerged to fill roles that had been left vacant. Yet, the underlying structure of ecosystems, based on the flow of energy from plants upward, reestablished itself across the planet. Within this gradual return, crocodilians remained part of the landscape, their presence bridging the time between what had been lost and what was forming anew. They did not lead the recovery, nor did they dominate it, but they endured within it, continuing their quiet existence as life, in all its forms, slowly found its way back. There are ways of living that depend on constant refinement, and there are ways that endure by remaining close to what already works. In the shifting world that followed, the difference between these approaches became increasingly clear. For crocodilians, survival did not require a new form or a rapid transformation. It rested on a set of traits that had already aligned with a wide range of conditions long before those conditions began to change. Their bodies were not built for a single narrow role. Instead, they functioned across multiple environments and situations without relying on precise circumstances to remain effective. Movement between water and land, a flexible diet, and a metabolism suited for conservation all formed a system that could continue without needing immediate adjustment. When the environment shifted, these traits did not become obsolete. They remained usable, requiring no rapid modification to match new conditions. In contrast, many other species had evolved toward greater specialization. Their forms and behaviors were closely tied to specific resources, temperatures, or ecological roles. In stable environments, this specialization allowed for efficiency and success. Yet when those environments changed quickly, the same precision became a limitation. Traits that had once provided advantage could not easily be redirected, leaving little room for adaptation within the available time. Crocodilians avoided this constraint by occupying a broader functional space. Their feeding habits did not depend on a single type of prey, and their activity patterns could adjust without disrupting their survival. Even their reproductive strategies, while not immune to change, did not require highly specific conditions to proceed. This generalist approach did not maximize performance in any one area, but it ensured that no single change could remove all available options. The value of stability became more apparent as conditions remained uncertain over extended periods. Rapid adaptation requires consistent selection pressures and time for changes to spread through populations. When environments fluctuate unpredictably, stability within existing traits can provide a more reliable path. Crocodilians did not need to develop new structures or behaviors to meet each shift. Their existing traits already covered a range of possibilities. This does not mean that change ceased entirely. Subtle adjustments continued, shaped by the conditions that persisted over longer spans. Yet these changes occurred within an already functional framework, refining rather than replacing what was present. The core structure of their biology remained effective, reducing the need for significant transformation. The idea of being good enough takes on a different meaning in this context. It is not a lack of development, but a balance between capability and flexibility. Traits that perform adequately across many conditions can become more valuable than those that excel in only one. In a world where predictability has diminished, the ability to function under varied circumstances outweighs the advantage of peak performance in a single stable setting. This balance also supports continuity across generations. Offspring inherit a set of traits that remain relevant without requiring immediate change. Survival does not depend on rapid shifts within each new generation, but on the consistent application of a strategy that has already proven effective. Over time, this continuity allows populations to persist even as the broader environment continues to evolve. Within this framework, crocodilians did not need to outcompete or replace other forms of life. Their success was quieter, defined by persistence rather than expansion. Stability, once simply a characteristic of their way of living, became a central advantage, allowing them to remain present through changes that disrupted more specialized paths. Across long stretches of time, change does not always appear as visible transformation. Sometimes it settles into a quieter pattern, where forms persist with only subtle adjustments, shaped more by what continues to work than by the pressure to become something new. In crocodilians, this pattern emerges clearly, not as a pause in evolution, but as a shift in how it expresses itself. Their body plan, already established before the Great Disruption, remained suited to a wide range of conditions that followed. The arrangement of limbs, the structure of the skull, the positioning of eyes and nostrils, all continued to function effectively within the environments they occupied. There was no immediate disadvantage to these traits, and without strong pressure to change, they were carried forward largely intact. Natural selection does not always favor novelty. It responds to the balance between an organism and its surroundings, preserving traits that support survival and reproduction. When that balance is maintained, even in a changing world, there is less need for significant alteration. In crocodilians, the traits that had supported their persistence through earlier conditions continued to provide the same advantage as ecosystems slowly reformed. This does not mean that evolution ceased. Small variations still occurred within populations, as they do in all living systems. Differences in size, behavior, and physiology emerged over generations, shaped by local conditions and interactions. Yet these changes remained within the boundaries of an already effective design, refining rather than redefining the form. The environments they occupied also contributed to this stability. Rivers, lakes, and coastal regions, while not unchanged, offered a continuity that allowed existing traits to remain relevant. These habitats did not demand entirely new strategies for survival, but rather rewarded those that could maintain efficiency and flexibility. Crocodilians, already aligned with these conditions, continued to function without needing to diverge dramatically. In contrast, other lineages experienced stronger pressures to adapt, leading to more pronounced changes over time. New niches emerged, and species that could evolve rapidly to fill them found opportunities for expansion. Crocodilians did not follow this path. Their niche remained consistent, and their role within it did not require extensive modification. The pace of change, in this case, reflects the absence of necessity rather than a limitation. Evolution operates most visibly when conditions create clear advantages for new traits. When those conditions are less defined, or when existing traits remain sufficient, change proceeds more gradually. This slower pace can give the appearance of stillness, yet beneath it, the same processes continue to shape populations over time. Their persistence, through millions of years, with relatively little alteration in overall form, illustrates this balance. The core structure of their bodies continues to meet the demands of their environment, allowing them to function effectively without extensive redesign. Subtle adjustments occur, but they do not accumulate into drastic transformations because the conditions do not require them. This continuity is not a sign of stagnation, but of alignment. Crocodilians occupy a space where their biology and their environment remain in agreement, reducing the need for rapid change. Evolution, in this context, becomes a process of maintenance and fine tuning, preserving what works while allowing for minor variation. Over extended periods, this approach supports long term survival. By maintaining a form that continues to function across changing conditions, crocodilians demonstrate that evolution can favor stability as much as innovation, depending on the balance between an organism and the world it inhabits. Not every survivor steps forward when space opens. Some remain where they are, holding to familiar paths while the wider world rearranges itself around them. In the long aftermath, as new forms began to appear and spread, crocodilians did not rise to claim the emptied ground. They continued along the margins, where water and land meet, keeping to a way of life that required little from the shifting center. Their presence was steady but understated. In rivers that wound through recovering landscapes, in lakes that gathered what returned, they remained close to the surface, often still, often unseen. The same posture that had served them before continued without change. Eyes and nostrils just above the waterline, the rest of the body held beneath. Activity came in brief moments, then faded again into quiet observation. This position placed them outside much of the competition that shaped the land. As mammals began to diversify and explore new roles, they occupied spaces that demanded different behaviors and energies. Movement across open ground, rapid foraging, and the use of varied shelters became more common among these emerging forms. Crocodilians, by contrast, did not need to follow these paths. Their reliance on aquatic environments and edge habitats kept them separate from many of these interactions. Avoidance, in this sense, was not an active withdrawal, but a continuation of an existing pattern. By remaining within waterways, they encountered fewer direct challenges from animals adapting to terrestrial life. Encounters that might have led to competition or conflict were reduced simply by occupying a different set of conditions. Their needs, already aligned with these environments, did not require expansion into newly available niches. This quiet persistence also limited their exposure to rapid change. Areas away from water experienced greater shifts as new species established themselves and interactions became more complex. Along the water's edge, the pace remained more measured. Crocodilians moved within this slower rhythm where the balance between activity and stillness remained familiar. Their role within these environments did not expand dramatically. They continued as ambush predators, relying on patience and efficiency rather than speed or pursuit. Prey that came within reach was taken, but there was no need to seek dominance over wider areas. This restraint kept their presence contained, preventing the kind of expansion that would place them in direct competition with the growing diversity around them. Over time, this approach allowed populations to stabilize. Without the pressure to adapt to rapidly changing terrestrial conditions, crocodilians maintained a consistent relationship with their environment. Reproduction, feeding, and movement followed patterns that required little alteration, supporting continuity across generations. Their lack of prominence does not indicate absence. Rather, it reflects a different kind of survival, one that does not depend on visibility or expansion. While other lineages diversified and spread into new roles, crocodilians remained within their established space, contributing to the developing ecosystems without reshaping them. In this way, they persisted through a form of restraint. By not seeking to dominate the new world that was forming, they avoided many of the challenges that came with it. Their survival was tied not to change, but to continuity, a steady presence within waterways that carried forward through time while the rest of the landscape evolved around them. The shape of the land did not remain empty for long. As the long, quiet intervals passed, new patterns began to take form, not as a return to what had been, but as a reorganization built from what remained. The absence of the largest reptiles altered the balance in ways that allowed different lineages to expand, each finding space within a world no longer defined by towering bodies and familiar movements. Vegetation, once sparse, continued to spread across recovering regions, forming the base for new interactions. With this growth came opportunities for smaller animals to increase in number and variety. These early communities did not mirror the complexity of the past at first, yet they carried the beginnings of a different structure, one shaped by organisms that required less and adapted more quickly to the shifting conditions. Mammals, which had existed alongside earlier forms for long periods, began to diversify more noticeably within this changing environment. Their small size and varied diets allowed them to occupy roles that were previously limited or unavailable. Some moved through dense undergrowth, feeding on plants or insects, while others explored open areas, adjusting their behavior to match the conditions they encountered. Over time, these differences expanded, giving rise to a wider range of forms, each suited to a particular set of circumstances. This diversification did not occur in isolation. As mammals spread into new niches, their interactions with the environment and with each other shaped the developing ecosystems. Patterns of feeding, movement, and shelter began to establish new balances, gradually increasing the complexity of life on land. The absence of dominant reptiles did not leave a void for long, but the replacements followed different paths, building a system that functioned in its own way. Above the ground, the lineage that had once included the great reptiles of the air continued in a more modest form. Birds, already present before the earlier changes, carried forward the connection to that past. Their bodies, lighter and adapted for flight, allowed them to move across recovering landscapes with relative ease. They fed on seeds, insects, and small animals, contributing to the flow of energy within the new ecosystems. Though smaller in scale, they represented a continuation rather than a complete break from what had come before. Within this evolving world, crocodilians remained where they had always been, along the edges where water and land meet. Their niche did not require expansion or transformation to remain viable. As new species filled the surrounding environments, crocodilians continued their quiet presence, interacting with the changing system without needing to alter their fundamental way of life. Their role remained consistent, shaped by patience and efficiency. They did not compete directly with many of the emerging mammals, whose activities were centered on land and required different behaviors. Instead, crocodilians operated within their own space, taking advantage of the resources that came within reach, while avoiding the complexities of the broader terrestrial competition. Over extended periods, these patterns settled into a new balance. The world without the dominant reptiles became one of varied forms and interactions, where size and specialization followed different trajectories. Mammals and birds expanded into roles that reshaped the landscape, while crocodilians persisted within their established boundaries. This new arrangement did not erase the past, but it transformed how life was distributed across the planet. Each lineage contributed to the emerging systems in its own way, creating a world that was both different from and connected to what had come before, held together by the same underlying processes that continued to guide life through time. Along certain waterways today, a familiar outline rests just beneath the surface, its form so closely aligned with deep time that it seems almost unchanged by the passage of millions of years. The arrangement of its body, the curve of its tail, the placement of its eyes, all echo a design that emerged long before the landscapes around it took their current shape. Modern crocodilians carry this continuity in a way that is both visible and functional. Their anatomy reflects a structure that has remained effective across vast spans of time. The elongated snout, lined with interlocking teeth, still serves as a precise tool for grasping and holding prey. The powerful tail continues to provide propulsion through water, while limbs support movement across land when necessary. Each part contributes to a system that requires no fundamental redesign to remain viable. Behavior follows the same pattern of persistence. Hunting strategies used today mirror those that existed in much earlier periods. Stillness, combined with sudden action, defines how these animals interact with their environment. They do not rely on extended chases or complex pursuit, but on positioning and timing. By remaining partially submerged and minimizing movement, they reduce detection and conserve energy until an opportunity presents itself. This approach extends beyond hunting into broader patterns of activity. Periods of rest dominate their daily rhythm, interspersed with brief moments of movement when needed. This balance between inactivity and action supports an energy-efficient lifestyle that aligns with their physiology. It is a pattern that has proven effective under a wide range of conditions, allowing it to persist without significant alteration. The environments they occupy today still resemble those of earlier times in key ways. Rivers, lakes, and coastal regions continue to provide the combination of shelter and access to prey that supports their way of life. While the species within these systems have changed, the underlying structure of the habitat remains compatible with crocodilian biology. This continuity allows ancient traits to function within modern ecosystems without conflict. Their presence creates a direct connection between present and past, Observing a crocodilian in its environment offers a glimpse into processes that have been ongoing for immense periods. The way it moves, feeds, and rests reflects behaviors that have been carried forward through countless generations. These are not reconstructed patterns or approximations, but living expressions of a lineage that has maintained its form through time. Subtle differences do exist among modern species, shaped by regional conditions and evolutionary pressures. Variations in size, snout shape, and habitat preference illustrate ongoing adaptation within the broader framework, yet these differences do not alter the fundamental design. They refine it, adjusting details while preserving the core structure that defines the group. This continuity is sometimes described as a form of living relic, though the term does not imply stagnation. Crocodilians have continued to evolve, but their changes have been incremental rather than transformative. Their success lies in the enduring effectiveness of their existing traits, which reduce the need for dramatic shifts in form or behavior. In this way, they serve as a bridge across time, linking modern ecosystems to those that existed long before. Their persistence is not marked by dominance or expansion, but by the quiet continuation of a design that remains suited to its purpose. Through them, the distant past is not entirely distant, but present in a form that still moves, breathes, and waits at the edge of the water. The phrase often arises in quiet discussions of deep time, spoken as a way to describe organisms that seem to stand outside the usual pace of change. Living fossil suggests something preserved, a form carried forward without alteration, as if time had passed around it rather than through it. Yet the reality behind this expression is more nuanced, shaped by how evolution operates when stability meets continuity. In scientific terms, a living fossil is not an organism that has stopped evolving. It is one whose overall form and function have remained relatively consistent over long periods, even as the world around it has changed. This consistency reflects a successful alignment between the organism and its environment, where existing traits continue to provide what is needed for survival. Change still occurs, but it unfolds within boundaries that preserve the core structure. Crocodilians offer a clear example of this pattern. Their bodies, behaviors, and ecological roles show strong similarities to those of their distant ancestors. The arrangement of their limbs, the structure of their jaws, and their approach to feeding all demonstrate continuity across millions of years. This resemblance creates the impression of an unchanged lineage, one that has carried its original design forward without interruption. Yet, beneath this outward stability, evolutionary processes remain active. Populations of crocodilians experience variation, with differences in size, shape, and behavior emerging over generations. These variations are influenced by local conditions such as climate, prey availability, and habitat structure. Natural selection acts on these differences, favoring traits that support survival within specific environments. Over time, these small adjustments accumulate, shaping distinct species adapted to particular regions. Some crocodilians develop broader snouts suited for varied diets, while others evolve narrower forms for capturing specific types of prey. Differences in growth rates, reproductive timing, and habitat preference further distinguish populations from one another. These changes are subtle compared to more dramatic transformations seen in other lineages, yet they represent ongoing evolution. The perception of crocodilians as unchanged arises from the persistence of their fundamental design. Their core traits continue to function effectively across a range of conditions, reducing the need for large-scale modification. When an organism's existing form remains compatible with its environment, evolution tends to refine rather than reinvent. This leads to a pattern where change is present but not immediately obvious. Misunderstandings of the term living fossil often stem from the assumption that visible similarity equals absence of change. In reality, evolution does not always produce dramatic differences in appearance. It can operate through adjustments in physiology, behavior, and genetic composition that maintain the outward form while improving internal efficiency or adaptability. Crocodilians illustrate how this process can support long-term persistence. Their ability to function within stable and variable conditions alike has allowed them to maintain their general structure while adapting in quieter ways. The result is a lineage that appears consistent when viewed across deep time, yet remains responsive to the environments it inhabits. This balance between stability and change highlights an important aspect of evolution. Success does not always require transformation into something entirely new. In some cases, it involves maintaining a form that continues to meet the demands of survival, while allowing for incremental adjustments that fine-tune its performance. Through this lens, the idea of a living fossil becomes less about absence of evolution and more about the continuity of a successful design. Crocodilians embody this continuity, carrying forward a set of traits that have endured not because they resisted change, but because they required only the smallest refinements to remain effective. At the boundary, where still water reflects the sky, a shape settles into place with such precision that it becomes part of the scene itself. Nothing announces its presence. No movement breaks the surface beyond a faint ripple that quickly fades. In this quiet arrangement, hunting does not begin with pursuit, but with the decision to wait. Modern crocodilians rely on ambush, a method that transforms stillness into advantage. Their bodies are positioned so that only the smallest portion remains visible, eyes and nostrils aligned just above the surface. From this vantage, they observe without revealing themselves, tracking movement at the edge where other animals approach to drink or cross. The environment becomes an extension of their concealment, masking their outline within reflections and shadows. Energy use remains carefully controlled throughout this process. Rather than expending effort in continuous search, crocodilians allow potential prey to enter their range. This approach reduces the need for sustained activity, aligning with their physiology, which favors conservation over constant motion. Each moment of stillness preserves energy that can be used in a brief, decisive action when the opportunity appears. When that moment arrives, the transition from inactivity to movement is rapid and focused. A sudden surge carries the body forward, driven by the tail and supported by limbs that guide the direction of the strike. Jaws close with force, securing the prey before it can react fully. This sequence unfolds in seconds, a concentrated release of stored energy that contrasts with the long periods of waiting that precede it. After the capture, the return to stillness follows just as quickly. Movement subsides, and the water settles once more, leaving little trace of what has occurred. This pattern, extended waiting followed by brief action, defines the rhythm of crocodilian hunting. It minimizes energy expenditure while maintaining effectiveness, allowing them to succeed without the demands of constant pursuit. Patience functions as a central element of this strategy. Time is not a limitation, but a resource, one that can be used to reduce effort and increase the likelihood of success. By remaining in place, crocodilians allow the environment to bring prey within reach, rather than seeking it out across larger distances. This approach aligns with their broader way of life, where efficiency and endurance take precedence over speed. Their sensory systems support this method of hunting. Subtle vibrations in the water provide information about movement beyond direct sight. Changes in pressure and motion signal the presence of potential prey, allowing crocodilians to respond with accuracy even when visibility is limited. This sensitivity enhances their ability to remain still while maintaining awareness of their surroundings. The techniques used today reflect a continuity that extends far into the past. The same reliance on concealment, timing, and controlled energy use has persisted across changing environments and shifting ecosystems. These methods do not depend on specific conditions, but on a general approach that remains effective wherever water and land meet. Within modern ecosystems, crocodilians continue to occupy their established role without significant alteration to this strategy. Their hunting does not require adaptation to new forms of pursuit or complex coordination. Instead, it remains grounded in simplicity, where success arises from alignment between body, behavior, and environment. This enduring approach illustrates how a method can remain effective over immense periods when it is built on principles that do not easily lose relevance. By combining stillness with precision, crocodilians maintain a way of hunting that continues to function as it always has, shaped by patience and sustained by efficiency. In wetlands, where water spreads into a network of channels and pools, balance is shaped by interactions that are often subtle and continuous. Within these systems, crocodilians occupy a position that influences far more than their immediate actions suggest. Their presence connects multiple layers of the ecosystem, guiding patterns that extend beyond individual encounters. As predators, they interact with a range of species that depend on the same environment. Fish, amphibians, birds, and mammals all move through these spaces, each following its own needs. Crocodilians do not consume all that they encounter, but their selective feeding affects which individuals persist and which do not. Over time, this influence shapes the composition of populations, preventing any single species from becoming too dominant. This regulation extends through the food web. When certain prey species are kept within manageable numbers, the resources they depend on remain available for others. Vegetation is not overused, smaller organisms are not depleted, and the flow of energy through the system remains distributed. In this way, the presence of a predator contributes to stability rather than disruption, maintaining conditions that support a wider range of life. Crocodilians also affect behavior in ways that are less visible but equally important. Animals that share their environment adjust where and when they move, avoiding areas where risk is higher. These patterns of avoidance distribute activity across the landscape, reducing pressure on any single location. Feeding, nesting, and movement become more varied, supporting a more balanced use of resources. Their interactions with the physical environment further contribute to this balance. Movement through water and along banks can alter small features of the habitat, creating or maintaining spaces where other organisms can live. Disturbances caused by their presence are not constant, but they introduce variation that supports diversity within the system. These changes, though localized, add to the overall complexity of the environment. The remains of prey left after feeding provide another link within the ecosystem. What is not consumed becomes available to smaller organisms, from scavengers to microorganisms, each playing a role in breaking down and redistributing nutrients. This process returns energy to the system, supporting life at multiple levels and contributing to the continuity of ecological cycles. In wetlands, where conditions can shift with changes in water level and climate, such connections are essential. Crocodilians, through their consistent role, help maintain these links even as other factors fluctuate. Their ability to persist within these environments allows them to continue influencing the system over long periods, providing a form of continuity that supports resilience. Their importance to biodiversity emerges from this combination of roles. By regulating populations, shaping behavior, and contributing to nutrient cycles, they support a variety of species that might otherwise struggle to coexist. The presence of crocodilians is not simply an addition to the ecosystem, but a factor that helps define its structure. This influence does not rely on dominance or constant activity. It arises from a steady interaction with the environment, where each action, though limited in scope, contributes to a broader pattern. Over time, these patterns reinforce the balance that allows diverse forms of life to persist within the same space. In modern wetlands, crocodilians continue to fulfill this role, linking past and present through their ongoing participation in these systems. Their presence sustains a balance that is not immediately visible, yet essential to the health and diversity of the environments they inhabit. In many places where water once spread freely, the edges have begun to narrow, shaped by changes that unfold not through natural cycles alone, but through the steady presence of human activity. Wetlands are drained or redirected, rivers are altered, and shorelines are reshaped to meet new uses. Within these transformed environments, the conditions that have long supported crocodilians become less consistent, and the spaces they depend on grow smaller or fragmented. Habitat loss does not always occur suddenly. It often proceeds in gradual steps, each one reducing the extent of suitable areas. A riverbank cleared of vegetation, a floodplain converted to another use, a waterway diverted from its natural course, all contribute to a landscape that no longer offers the same balance of shelter, temperature, and access to prey. As these changes accumulate, the continuity of habitat is broken, and populations become isolated within smaller regions. This isolation affects more than movement. It limits the exchange between groups, reducing genetic diversity over time and making populations more vulnerable to further changes. When conditions shift within a confined area, there may be no nearby environment to move into, leaving individuals with fewer options for adaptation or escape. Encounters with humans introduce additional challenges. Crocodilians, maintaining their presence along waterways, often come into contact with communities that share the same resources. These interactions can lead to conflict, particularly when animals approach areas used for fishing, agriculture, or daily activity. In some cases, crocodilians are removed or killed in response, reducing local populations and altering the balance within those ecosystems. Perception also plays a role in these interactions. Animals that remain hidden for long periods and move with sudden precision can be seen as unpredictable or dangerous. This perception can influence how they are treated, shaping decisions that affect their survival beyond the immediate encounter. Climate change introduces a more gradual but widespread set of pressures. Shifts in temperature and rainfall alter the timing and extent of water levels, affecting the habitats crocodilians rely on. Nesting sites, which depend on specific ranges of temperature and moisture, become less predictable. If conditions are too warm or too cool, or if flooding occurs at the wrong time, the development of eggs can be disrupted. These changes influence not only individual nests, but entire reproductive cycles. When multiple seasons are affected, the number of hatchlings reaching maturity may decline, altering the structure of populations over time. As younger individuals become less common, the long-term stability of these groups can be reduced. Conservation efforts seek to address these challenges, but they operate within a complex set of conditions. Protecting habitats requires balancing ecological needs with human use, ensuring that waterways and wetlands remain functional while supporting surrounding communities. This often involves creating protected areas, managing resources carefully, and working to reduce conflict through education and planning. Success in these efforts depends on continuity, much like the survival strategies of the animals themselves. Long term commitment, consistent management, and an understanding of how these ecosystems function are necessary to maintain conditions where crocodilians can persist. Each action contributes to preserving the environments that support them, allowing their role within these systems to continue. In the present day, the challenges they face differ from those of the distant past, yet they still center on the relationship between organism and environment. As conditions change, the persistence of crocodilians depends on whether the spaces they occupy can be maintained, allowing their quiet presence to remain within a world that continues to shift. Not all endings arrive as a test of power. Some unfold as a quiet shift in conditions where the qualities that once defined success no longer carry the same weight. In those moments, survival becomes less about dominance and more about how closely an organism's way of living aligns with what remains. The long persistence of crocodilians offers a reflection of this idea. Their survival did not depend on being the fastest, the largest, or the most numerous. Instead, it rested on a combination of traits that allowed them to function under changing circumstances without requiring constant adjustment. Their bodies, behaviors, and patterns of energy use formed a system that could continue operating even as surrounding conditions shifted. Strength, in the sense of physical capability, plays a role in many ecosystems, yet it does not guarantee continuity when the environment itself changes. Large size can require greater amounts of food, more stable conditions, and longer recovery times. When these supports disappear, the advantages of size may turn into limitations. In contrast, organisms that require less and can function with fewer resources often find it easier to persist. Flexibility emerges as a central element in this process. The ability to use a range of food sources, occupy different spaces within an environment, and adjust activity based on available energy allows an organism to remain active even when conditions are uncertain. This flexibility does not require constant transformation, but rather a design that accommodates variation without losing effectiveness. Efficiency works alongside flexibility, shaping how energy is used and conserved. Crocodilians illustrate this through their low metabolic demands and their reliance on strategies that minimize unnecessary movement. By reducing energy expenditure, they extend the time they can persist without external input, allowing them to endure periods when resources are limited. Environments, however, do not reward the same traits at all times. What proves effective in one context may become less useful in another. The history of life shows repeated shifts in which different qualities come to the forefront. Periods of abundance may favor growth and expansion, while periods of scarcity favor conservation and restraint. Organisms that can operate within both conditions without requiring rapid or extreme change often maintain continuity across these transitions. This perspective reshapes how survival is understood. It becomes less about competition in a stable setting and more about compatibility with change itself. Traits that appear modest or unremarkable can become central when conditions no longer support more specialized or demanding forms of life. In this way, survival reflects not only what an organism is, but how it fits within the shifting patterns of its environment. For modern species facing ongoing changes, Similar principles apply. As habitats transform and climates shift, the capacity to adjust within existing frameworks becomes increasingly important. Species that can alter behavior, expand their range of resources, or reduce their dependence on specific conditions may find pathways to persistence even as their surroundings evolve. Crocodilians embody this form of continuity. Their survival across deep time reflects a balance between stability and adaptability, where the core of their design remains effective while allowing for subtle adjustments. Through them, a broader understanding emerges, one that places emphasis not on extremes of strength or speed, but on the quiet alignment between organism and environment that allows life to continue. Along the edges of modern rivers, where cities may rise in the distance and human movement hums beyond the waterline, a quieter presence remains, one that carries with it a continuity far older than the surroundings it now inhabits. The shape resting near the surface belongs fully to the present, yet it also reflects a world that existed long before these landscapes took their current form. Crocodilians move through today's ecosystems with patterns that echo those of distant eras. Their posture in the water, their measured stillness, and their sudden, precise motion all mirror behaviors shaped in environments that no longer exist in the same way. These actions are not preserved as memory, but as living continuity, expressed through each moment of their daily activity. The connection between past and present becomes visible through this continuity. Modern wetlands differ from those of earlier periods in composition and detail, yet they maintain underlying structures that support similar forms of life. Water collects, flows, and settles. Vegetation grows along its edges. Animals gather to drink, feed, and move between habitats. Within these recurring patterns, crocodilians continue to operate using the same fundamental strategies that once guided them in ancient landscapes. This persistence reveals how certain ecological relationships endure even as specific species change. The roles within an ecosystem, predator and prey, shelter and exposure, energy and consumption, remain constant in structure, though their participants may differ. Crocodilians occupy one of these roles, linking present ecosystems to those that existed across deep time through the continuation of their function. Their presence offers evidence of resilience that extends beyond individual survival. It reflects the capacity of a lineage to navigate long sequences of environmental change without losing its essential form. This resilience is not based on resisting change, but on maintaining compatibility with it. By aligning closely with conditions that recur across different periods, crocodilians have been able to persist through shifts that altered many other lineages. In observing them today, there is an opportunity to witness this continuity directly. The surface of the water may reflect modern skies, yet the movements beneath it follow patterns established millions of years ago. Each action, from the slow drift along a riverbank to the brief surge of motion during a hunt, carries within it a history that is not distant but ongoing. This connection does not rely on dramatic transformation or visible contrast. It exists in the quiet consistency of form and behavior, where the past is present not as something separate, but as something that continues within the living world. Crocodilians do not recreate ancient ecosystems, yet they embody elements of those systems in ways that remain functional today. Through them, the passage of time becomes less a division and more a continuous thread. The environments have changed, the communities of species have shifted, and the conditions have evolved, yet certain patterns persist. Crocodilians move within these patterns, maintaining a link that stretches across vast spans without interruption. In this way, they serve as reminders that the history of life is not only recorded in fossils or layers of rock, but also in the organisms that continue to exist. Their presence carries forward the structure of earlier worlds, allowing it to remain visible within the present, where it continues to unfold quietly along the water's edge. At the edge of still water, where movement is measured and the surface carries only the slightest disturbance, a form remains that has outlasted worlds without ever seeking to control them. Its presence does not reshape the landscape in dramatic ways. It does not spread across every available space. Instead, it holds its position, existing within a balance that has proven durable across immense stretches of time. Crocodilians did not rise to fill the absence left by those that disappeared before them. They did not expand into dominance or redefine the structure of life around them. While other lineages transformed, diversified, and moved into new roles, they remained within the boundaries that had already served them. Their survival was not built on change at every turn, but on the ability to remain effective without needing to become something entirely new. This endurance reflects a pattern that runs quietly through the history of life. Survival is often associated with strength, speed, or complexity, yet these qualities alone do not guarantee persistence when conditions shift. Crocodilians illustrate a different path, one shaped by patience, efficiency, and a steady alignment with the environments they inhabit. Their bodies conserve energy rather than expend it freely. Their behaviors rely on timing rather than constant action. Their role within ecosystems remains consistent rather than expansive. Through this combination, they have continued without interruption, moving through periods of stability and upheaval alike. Their presence today is not the result of a single advantage, but of many small traits working together, each one contributing to a system that functions under a wide range of conditions. This integration allows them to endure without needing to compete in every dimension. The continuity they represent extends beyond their own lineage. It reflects how life itself persists, not as a constant ascent toward greater dominance, but as a balance between change and stability. Some organisms adapt through transformation, reshaping themselves to meet new challenges. Others maintain a form that continues to fit within shifting environments, adjusting only where necessary. Both paths exist, each shaped by the conditions that surround them. In the quiet presence of crocodilians, this second path becomes visible. Their survival does not draw attention through dramatic change, yet it carries a depth that spans millions of years. Each movement, each moment of stillness, connects to a history that has unfolded without interruption, carried forward through continuity rather than reinvention. As the story settles into the present, the question of survival becomes less about what is most powerful and more about what is most fitting. The traits that endure are those that remain aligned with the conditions of the world, whether those conditions are stable or shifting. In this alignment, life continues, finding ways to persist even when circumstances change in ways that cannot be predicted. Within this reflection, there is space to consider which aspects of this endurance stand out most clearly. Some may rest in the efficiency of energy use, others in the flexibility of behavior, or in the patience that allows time itself to become an ally. Each of these elements contributes to a broader understanding of how survival unfolds across deep time. From this perspective, the quiet survivors remain not as exceptions, but as examples of a path that has always existed. Their story continues alongside countless others, each revealing different ways in which life adapts, persists, and moves forward. Beyond this moment, there are many such stories waiting within the natural world, each offering another glimpse into the patterns that shape existence across the ages.